BA bar. Okay. So AB bar plus BA bar. So in this, let us discuss for this. AB bar plus BA bar is nothing but A XOR B. A XOR B. Don't read like that A plus B. A plus B is for OR gate. Okay. So A XOR B. Now I am drawing this. These are the inputs. So this is B bar. Which gate it is? Not gate. AND gate. So what is the output? AB bar. Another AND gate is there. BA bar. Before the NOT gate, this is B. This is a NOT gate. This is A bar. Okay. A and A bar. So what is the output here? Here. These two you have to add. OR gate. AB bar. So this is the logical representation which is related to the XOR gate. By using the basic logic gates, we have been constructed the XOR gate. Okay. So this is the XOR gate symbol. XOR gate. But you need to draw the truth table for this. What is the truth table? A bar. What is A bar? 0 means 1. 1 means 1 means next 0 means 1. 1 means 0. 1. AB bar. A into B bar. A into B bar. 0 into 1 0. 0 into 0 0. 1 into 1 1. 1 into 0 0. Next BA bar. These two product. 0. 1 into 1 1. 3 into 0 0. 1 into 0 is 0. So what is this? You need to add these two. 0 plus 0, 0. 1, 1, 0. So what do you understand from this? If any one of the output, if it is high, okay, anyone, the output is high. If both the inputs either high or low, the outputs are 0. Okay, here low, high. Okay, so output becomes, so here in this condition, high. Getting my point? So this is about the XOR gate. So you should be very careful with this XOR gate. But where we are using this XOR gate, now we will discuss another one. Next important is half adder. Okay. So before going to discuss about the half adder, let you know some if 1 plus 1 is there, some 0 carry 1. Okay now. So these are the conditions. So let you draw for the logical representation of the half adder. This is AND gate. And okay. So input we have two things. So what are these? These are the inputs, outputs. So that you can able to observe the case for the sum and carry, sum and carry. Okay. Half adder, half adder. So how many inputs are there? Two inputs are there. So maximum number of combinations. Four combinations. Okay. So while you are adding two bits. So how it gives the output for half adder. Input is four combinations. 0, output A dot B, A XOR B. This is sum A dot B. Again, A XOR B. In previous section, we already discussed that either any one of the input is high, the output will become high. Both the zeros are there, 0, high, high. What is the AND gate for the A dot B? 0.00, 0.10, 1.00, 1.1 is high. Okay. So that for XOR gate, some value should be 0, 1, 1, 0. Carry should be 0, 0. Okay, now. So suppose these two bits we are adding. Okay. So which one you are adding? These two. A1, B is 1. 1, 1. Add 1 plus 1. Sum 0. Carry 1. Sum 0. Carry 1. Substitute these values in this sum equation. A is 1. One dot one. One. So that sum is G. What about the carry? Carry 1. Carry 1. Sum 0. So you can sum 0. So like this, in examination point of view, in examinations, you need to derive and substitute these all values, and you have to represent like this. Okay, then only you will get the marks. Getting my point? Next. So what about the full adder? So if input is 2 bits for half adder, it may generate sum and carry. Okay. If 2 bits are there, 4 combinations. But what about the more than 2? So there only we are taking full adder. Full adder means half adder plus half adder is full adder. 2 half adders. That means how many combinations you may get here? Why? Because of n is 3. Formula is 2 for n. 2 cube means 8 combinations. Is it clear? But in full adder, how to give the inputs values? 8 combinations. A, C. Okay. 8 combinations now. Starting with 0. Write down. 8 zeros. 1, 2, 3, 4, 5, 6. One, two, 8 by 2. So 4 zeros, 4 ones. 4 zeros. Okay. Next again, how many zeros are there? In 4 zeros, 2 zeros, 2 ones. Combination. Okay. 2 zeros, 2 ones. Again, 2 zeros, 2 ones. Next, here only 2 zeros are there. In 2 zeros, 1 0, 1 1. Starting with 0 only. So like that, this is the simplest. If 16 bits are there, hexa, there also 16 by 2 means 8. 8 zeros, 8 ones. Again, out of 8, 8 by 2, 4 zeros, 4 ones. 4 by 2, 2 zeros, 2 ones. Like this. So this is the simplest method. Next, you will get the sum carry that you need to work out. So what are the sum values for these input values? What are the carry values? You need to write. Okay, that means full adder How many inputs are there? Inputs are 3, where the outputs is some. Okay. So this is about the full add, and you need to practice it, and you can easily get the values. Either for sum or carry, like this. Next one is the NAND gate. That is RS or SR flip flop. Okay. So RS flip flop. What do you mean by flip flop? Flip flop, it can store one bit. Okay. So flip flop, it can store one bit of information temporarily, just like a register. Okay, all these you can read out in the case of microprocessor, microcontroller, their own. Okay, so that is the case. But before going to discuss this RS flip flop, it contains two NAND gates. Input. Okay, so let you. What is AND gate? A, B, AND gate. Okay, input, out, table, truth table. Okay, so this is about the AND gate. NAND gate. AND gate, it should followed by the NOT gate. Okay, or so AB bar. You already got the output for the AND gate. What is the AB bar? 0 bar, 1, 0 bar, 1, 0 bar, 1, 1 bar. So this is the output for the NAND gate. This is the output for the AND gate. Okay. So you can easily observe the cases for the NAND and AND. The AND gate, NAND gate is nothing but a complement of the AND gate. Complement of the AND gate is nothing but a NAND. Okay. So now our focus is on RS flip flop. RS flip flop. Getting my point? Like this, you have to connect. This is the circuit diagram for RS flip flop. Practice it. That means what you are getting here, the output of the one which is connected to the input for the second NAND gate, and the second NAND gate output is fed to the one of the input for the first one. Getting my point? So for NAND gate, 0, 0, 0, 1, 1, 0, NAND gate's output is high. But when these, okay, for these cases, if both the inputs are high, the output is low. Okay, now. Suppose if S is 0, R is 1. S 0, R 1. If 0 is there, 0 bar is 1. Again, this 1 is fed to here. 1, 1. What is output? Getting my point? 1, 1 is output. This case, this is, you can call it as a set. Okay. Start set. Next is this is the first case. One minute. What is the other condition? I will check out. So this is a set state. This you can call it as a stable state. Okay. Next is the S0 R. Next S1 R1. S1 R1. This is the first case. S equals to 1, R equals to S1 R1. If S1, what is the output? 0. Again here 1 0. What is the AND gate for the 1 0? 1 0 is okay. This you can call it as reset state. This is also other or another stable state. Is it clear? Like that 0 1 1 1 0 1 1 1, you haven't completed this. 0 0 0 1. The different conditions cases you may apply. So which one is the set state and which one is the reset state, you can easily find out. So I will share you. You can observe here. Which one is the set state? If input is 0, 1. 0, 1 means Q1, Q bar is 0. Next, both the 1 1 is there. If 1 1 is there, here you can see in reset state 1 1, Q0, Q bar is 1. This is reset. This is set reset. Okay. Apply the condition at input. What do you have the output values? We can easily identify. So here we have to apply to the S and R inputs of the flip-flop. So we cannot directly apply the S and R inputs. So that it is very difficult to us to overcome this. 2 inverters are incorporated in each of the input. Okay. So S means S bar, R means R bar. These are the inverters. So, and then at input terminal. So we can give and send the signals through these two inputs directly. So these flip-flops, which are called also a latches. What do you say? Latches. Latches. Or you can say latch. Latch. You can see here latches or latch of this S and R inputs, which have been given out here. S bar and R bar. Okay. So this is Q and Q bar. So what is the truth table for this? We can go for this. Truth table SR. Q is remember the last state and Q bar is the last state. Remember 0 0. 1 0 means 1 and 0 set. If Q bar is 0 set and Q bar is 1 reset. Okay. So if both the inputs are high, that is a forbidden state. Next is the clocked RS flip flop. So you can observe this clock, the RS flip flop. So some of the applications become necessary to set or reset. Q bar should be 0 and 1 for the RS flip flop, which is in a synchronized with the clock or trigger pulse. Okay. So the RS flip flop studied in previous section and which have been modified into clocked RS flip flop. So it may be response here. So this is the clocked RS. Okay. This is A, B, C, D. Q bar, Q bar. Oh. Q and Q bar. So here, this is the clock. Okay. This is 0, 1. 0 and 1. 0, 1. Clocks have the clock which has been 0, again 1, 0, like that. So how you are giving the input is a clock, this is here. So that in this case, when clock input is 0, so the output of the each gate A and B is equals to when the clock inputs are 0. Okay. In this case, gate A and B 0 means A and B, which equals to 1, and which is going to be 1 means forbidden. Okay, that means which can be disables the flip-flop, so the output do not changes. Okay, when the clock is 1, when the clock is 1, so if S and S is 1 and R is 0, S is 1 and R is 0, QA is 0 and QB is 1. Okay, 0 is fed to 1, 0, 1 means 1 here. So which in turn with here Q1 is 1 and this is Q1 is 1, and again if it is Q bar, here 1 is there, that becomes 0. That means this is set. So that here the data which is given at the input, which may be passes to the output only when the clock input is at high. For lower, it does not allow. Getting my point? Please remember this. So, which may gives you here RS flip-flop, clocked RS flip-flop, R and S. Okay. So Q plus 0, 0, Q, 0, 1, 1, 1, 0, 0, 1, 1 is forbidden state. Okay. So in this, what is RS flip-flop? So other one is the D flip-flop. So this is also another important question. D flip-flop. This we will discuss in tomorrow's class. Better to recall that what we have been discussed today. And also, I will share you. See the full adder truth table. You can see here. Full adder. See full adder. Okay. So how many AND gates are there? These are the AND gates. 1, 2, 3 AND gates. This is the one OR gate. This is the one XOR gate. XOR gate always gives you sum. AND gates always gives you carry. To add all these carries which are generated from the 3 different AND gates, we are using OR gate. Why? Because of OR is going to be gives the summation plus. First AND gate, second AND gate, third AND gate. Getting my point? So that here another input terminal is also there. That is not printed here. That means one gate is AB, other gate is BC, other gate is CA. Okay, AB, BC, CA. First gate is BC. Here C and B. This is output is BC. Here C and A should be there. This is CA. This is AB. By adding all AB plus BC plus CA, okay, we are using this so that may gives you carry. Okay, so A XOR B, the output is A XOR B value. We can call it as D. Then D XOR C, some value. So that is here sum. You will get the sum value. Okay, getting my point? So that you need to work out full adder also. So this is the truth table for us. So these are the input values. 3 different input values A, B, C. Okay. How to remember 4 zeros and 4 ones and like that. What is the S means some value, C means carry. How it is generating. That means more than 2 inputs if you are going to be using, and if you want to add it, there only we are using these full adders. Okay. So I think so you got an idea how to construct the full adder, how to construct the half adder, and we have been discussed about the XOR gate, and similarly the what is that RS flip flop. Half adder is also there, full adder is also RS flip flop, and clocked RS flip flop also. Okay. So by tomorrow's class, we will discuss about the D flip flop. Which one? D flip flop. Okay. So I'm signing off. Thank you. Thank you, one and all. All the best.